This satellite view shows the Indian subcontinent's fractured geography. Up at the top edge is a massive wall of white snow. Below sits a sprawling stretch of flat plains, abruptly giving way to a darker, rugged plateau covering the southern half. How did three distinct environments end up crammed together on a single, isolated piece of land? To make sense of this map, you must stop looking at it as a static drawing. What you're actually seeing is the wreckage of an ancient planetary-scale collision. Rewind 200 million years. India was locked inside Gondwanaland, an ancient landmass that split into South America, Africa, Antarctica, and Australia. But the Indian plate broke off completely, drifting rapidly north across a vast ocean on its own. Waiting ahead of it was a massive, stationary target, the giant Eurasian landmass, known to geologists as Angara Land. You have an incredibly heavy geological force accelerating straight toward an immovable object. When that Indian plate finally slammed into Eurasia, the physical impact forged the three main geographic zones of modern India. Think about what happens when two cars hit head-on. The metal has nowhere to go but up. When these two continental plates collided, the immense compression forces buckled the Earth's crust, shoving billions of tons of rock straight up into the sky. That massive upward fold created the Himalayas. The sheer violence of the crash pushed the highest peaks, known as the Greater Himalayas or Himadri, into a permanent freeze. This diagram shows the stepped architecture of those mountains. Moving south from the extreme peaks, the elevation drops into the middle Himalayas, and finally down into the outer foothills called the Shivaliks. The Himalayas are often drawn as a simple borderline, but they are actually an active crumple zone. The tectonic crash is still happening, and those peaks are still rising today. Pushing all that rock upward had a secondary effect. It created a severe dip, or a massive deep basin, immediately south of the new mountain range. Over millions of years, glacial melt and heavy rains formed massive river systems that rushed down the steep slopes and emptied directly into that depression. Look at this block diagram showing the flat regions sitting between the Himalayas and the Central Highlands. Those rushing rivers carried billions of tons of alluvial soil, silt, and gravel with them, gradually filling that deep basin all the way to the brim. Alluvial soil is a fine-grained, highly nutrient-rich dirt deposited by flowing water. Once leveled off by sediment, this filled-in basin became what we now call the Indo-Gangetic Plains. Because that specific fine-grained dirt traps water and nutrients so efficiently, this entirely flat geological fill-in is incredibly fertile, allowing it to support one of the most densely populated human regions on Earth. To find the original piece of landmass that actually caused the collision, we have to look away from the crash site and move down to the southern half of India. This block diagram shows the raised peninsular plateau. Unlike the crushed rock up north, this southern block is ancient crystalline rock, surviving intact from Gondwanaland. Notice the distinct tilt. The plateau is pushed much higher on the western edge, sloping gently downward toward the east. This tilt creates two completely different borders. The western edge forms a towering, unbroken wall known as the Western Ghats, while the eastern edge breaks apart into lower, fragmented hills. While the north is a volatile product of a recent tectonic collision, this stable southern block has been quietly holding its ground for hundreds of millions of years, acting as India's foundational rock and an enormous vault of mineral wealth. Let's pull back to this globe map showing India's position relative to Asia and the oceans. If you look at all three zones together, they stop looking like separate features and start acting like interconnected gears in a single geographic machine. Up north, the massive Himalayan crumple zone acts as an impenetrable physical shield. It physically blocks the freezing winter winds blowing out of Central Asia from ever reaching the subcontinent. In the summer, that exact same mountain wall does the reverse. It traps warm, moisture-heavy monsoon clouds rolling in from the ocean, forcing them to drop their water and continuously feed the river systems running through the fertile plains below. Meanwhile, the heavy tilt of the southern plateau dictates exactly how water moves across the rest of the landmass, steering the flow of major peninsular rivers eastward until they empty into the Bay of Bengal. Every part of this continental engine, the water flow, the climate defense, the agriculture, is entirely driven by the extreme variations in elevation that were born out of that single tectonic crash. Because the Indian plate hasn't stopped moving, the tension is still there, India remains an active, shifting geological theater, and the map we know today is quite literally still being drawn.